This is a video to help you learn how to name compounds, also called nomenclature. So you can use this to help with your Lab 6, or you can come back to this and review it. In either case, I'm going to go through this pretty quickly, but you should be stopping this and pausing the video in order to be able to learn how to do these things on your own, instead of just watching me do it. So the first thing we're going to start with on page 3 of your labs is naming the ionic compounds with predictable charges. And so to name them, you say the cation first, you just say the name of the element, and for the anion, you change the name of the elements, the ending to ide, IDE, and that is the one you say second. So for MgCl2, that would be called magnesium chloride. NaF would be sodium fluoride. And BeO would be beryllium oxide. So go ahead and pause this and try the other examples in that table, and then come back and we'll change the slide now and give you the answer. The answers are magnesium selenide, potassium iodide, silver bromide, aluminum oxide, and zinc chloride. So the next thing we have to be able to do is to go the other way and figure out the formula from the elements that you're putting together. And so the first ones we're trying to have a predictable charge, which means that you have to use what we've learned about the valence electrons and the periodic table to know what charge these ions tend to have. So as we've talked about before, the group 1 elements form cations with a +1 charge. The group 2 form a +2 charge. Aluminum over in group 13 forms a +3 charge. And then coming from the other direction, the group 17 elements form a -1, the group 16 form a -2, and group 15 form a -3 charge. So that makes them like the noble gases, that they're trying to be like those. The other 3 metals listed always form the same ion, and so they are predictable as well. Zinc always forms a +2, cadmium always forms a +2, and silver always forms a +1. All right, so once you know the charges of these ions, you just have to add up enough of each one so that the total formula gives a charge of 0. For example, for silver sulfide, silver is a +1 and sulfide is a -2. So you need 2 of the silver +1 to balance out and give you a 0 charge. And the formula for that would be Ag2S. So go ahead and try magnesium bromide, zinc oxide, potassium phosphide on that table. Okay, now we're back, so we'll get you the answers. So magnesium bromide would be MgBr2, zinc oxide would be ZNO, and potassium phosphide would be K3P. I've saved calcium nitride for last because that's the trickiest one. Go ahead and try that before you look at the next slide. All right, so calcium nitride, calcium is a +2 and nitrogen is a -3, so you have to get those to balance. One of each gives you too much negative charge. If you add another calcium, it's too positive. So then you keep going back and forth, add another nitrogen, and then finally when you add another calcium, you have a total of +6 from the 3 calciums, -6 from the 2 nitrogens, and so that's just right. The formula Ca3N2 gives you a total charge of 0 in that compound. All right, so the next tables are dealing with transition elements, which can have more than one type of charge. And so since they're not predictable, we have to specify which one we're talking about with a Roman number. And we still have to balance to give a 0 charge like we were doing with the other compounds. So for example, tin 2 chloride, tin can form a +2 or a +4. Since we called it tin 2 chloride, we're specifying that we're talking about the tin +2. And then chloride is always -1, and so we need 2 of those to balance. And so the formula for tin 2 chloride would be SnCl2. Mercury 1 sulfide needs to be specified because mercury can be +1 or +2. We're talking about the mercury +1, and so we need 2 of those in order to balance the sulfide, which is a -2. So that would be Hg2S. Go ahead and pause before we give the answers for the remaining ones on that table. Okay, so we'll give the answers to those. The nickel 3 oxide, 2 of the nickel 3 is a +6, and that would balance with 3 of the oxide to give a -6. FeO is the iron 2 oxide formula, and AuN is the gold 3 nitride formula. All right, so when we name with the transition elements, we do have to put the Roman number and tell which of the ions we're talking about. We also have to figure out which of the ions we're talking about. That's why the table is set up like it looks on page 4 of your lab. We have to figure out from the anion what the cation charge is. So for example, with the lead and sulfur, we know that sulfur has a -2 charge. So we need a total positive charge of +2 to balance out the one sulfide. And so we only have one lead atom to do that, and so that lead atom must have that +2 charge. So we must be talking about lead 2 sulfide. Another example with the tin and the 2 oxygens, 2 oxide have a total negative charge of -4. And so we would need a +4 to balance that. And we have one tin atom to do that with, so that one tin atom must be a +4 charge. So we have to call that tin 4 oxide. So skip down a couple of examples and try the one with copper and sulfur. And we'll assume that you've tried that and you're back. Let's take a look at the copper and sulfur. We have one sulfide giving a -2 charge, and so we need a total positive charge of +2. We have 2 copper atoms in that compound to give the +2 charge, and so each of the copper must be +1. So we have a copper +1 and a copper +1, and then a sulfide -2, and that balances out to 0. So that compound is copper 1 sulfide. So now you can go back and try the rest of the examples on that table. Okay, we'll assume that you've tried those. And so here are the answers: gold 3 chloride, chromium 3 bromide, and mercury 2 oxide. So the next tables are going to be using some polyatomic ions. And so these are ions that are made of a group of atoms. And so you have to learn what those polyatomic ions are: the name, the formula, and the charge. And so that table is located in your lab pages on page 4. It's also in your textbook. So we're going to go ahead and do the same thing using the anion to figure out what charge we have on the transition element. So this PbSO4. SO4 is a sulfate ion. It has a -2 charge. And so we can figure out that we need a positive charge of +2. So that means our one lead atom must have a +2 charge. We have Pb +2, and the name of that compound would be lead 2 sulfate. So go ahead and try the other examples on that table. You can use the polyatomic table when you first get started, but eventually you are going to have to know those polyatomic ions and be able to do it without that table. Okay, so let's assume that you're back and take a look at the answers. Those names would be iron 3 phosphate, copper 2 sulfate, lead 4 acetate, and gold 1 carbonate. So the next table, we are using polyatomic ions, but we're back to the predictable charge elements, and so we don't have to specify with Roman numbers in the name. Go ahead and give that a try. All right, and we'll say that you are back, and we'll take a look at the answers. So barium nitrate, again, barium always has a +2 charge, so we don't need to specify. Sodium carbonate, silver nitrite, potassium cyanide, and then the last example can either be called lithium bisulfite or lithium hydrogen sulfite. Either one of those is accurate. Okay, so when you have the polyatomic ions, you do the same process for figuring out the formula. We need silver nitrate as our first example, so we know that silver is a +1. We also know that nitrate is an NO3 -1 group. So you need one of each group to balance and make a 0 charge. AgNO3 therefore works for that compound. The next compound combines magnesium +2 with a hydroxide, which is a -1. And you need 2 hydroxide to balance the 1 magnesium. You have to write that Mg then with parentheses, OH2. You need those parentheses because you don't just have 2 hydrogens. You can't just say MgOH2. You need the parentheses to show that you have 2 hydroxide pieces, not just 2 hydrogens. So that's important to have those parentheses when you have more than one of the polyatomic ion. All right, so go ahead and try the formulas of the sodium bicarbonate, calcium phosphate, and potassium sulfate on that table. And we'll go ahead and get the answers now. Those are the formulas for the sodium bicarbonate, calcium phosphate, and potassium sulfate. So for covalent compounds, those elements combine by sharing electrons, not by forming ions. And so we can't do this math to predict what the formula is going to be, and we have to use the name to tell the different pieces that we have. For example, CS2, we have 1 carbon and 2 sulfur. The first one we can just name carbon, and then the sulfur we change to sulfide, and we say disulfide because we have 2 of them. Phosphorus, PBr5 would be phosphorus pentabromide. And then I just wanted to point out the carbon monoxide example. It's not on your lab sheets, but it does illustrate some things that we have to remember. So we have 1 carbon and 1 oxygen. If the first element has just 1, we do not have to say that it's monocarbon. We can just drop the mono for the first element only. But for the oxide, we do have to keep that mono. So that compound is called carbon monoxide. We don't have to say monocarbon monoxide, but we do have to say carbon monoxide. Okay, so we have some more covalent compounds for you to try. The first element does not have to change the ending, but the second one does. I did want to point out that the prefix mono is the only one that we get to drop. If the first element, there's only one of the first element, you can drop the mono. But for example, the next example, N2O3, for that nitrogen, we do not get to drop the prefix. We still have to use the prefix. So the only prefix we get to drop is mono. So keep that in mind as you try the next examples. And then we'll assume that you're back and we'll give you the answers. Give the answers here. So here are the answers for that table. Dinitrogen trioxide, sulfur hexafluoride, SBr2, B2O3, iodine tribromide, and tetraphosphorus triselenide. So our last table has some hydrate examples, and it also has the answers. So if you wanted to try those on your own, go ahead and do those now. All right, I guess if you're back, we'll take a look at hydrates. And for hydrates, the first part is an ionic compound, and so you can use that to practice what we've been learning. The second part is a certain number of water molecules that are loosely bound to the structure. Since we can't tell how many water molecules are going to be there, we have to use the prefix that we used for the covalent compounds we just did. So for example, that first compound listed is copper 2 sulfate. That's the first part, is named copper 2 sulfate. And then the water part is called pentahydrate because there's 5 waters. If we wanted to draw tin 4 chloride pentahydrate, the formula for tin 4 chloride is SnCl4, and then pentahydrate is 5 waters. And then that last example is magnesium sulfate heptahydrate because it has 7 waters. So these hydrates are not going to be on the exam, although you do have to know how to name ionic compounds like magnesium sulfate and tin 4 chloride. But we are going to be seeing some hydrates in lab, so I thought that I would put them on here. So I need to finish up for now to make this a shorter video, but feel free to go back and review as many times as you find helpful. Thank you.